Hello. I'm getting progressively scruffier as this goes on. So, how's everybody doing this morning? Do I have a cat or... Oh, there he is over there. This back means some music. So I actually played music and I didn't realize it was coming... It wasn't coming through. So, I'll have to figure out why that didn't work and try next time. Yeah. So how's everybody doing? Hope you guys are good. Slides say Project 1 is due on Friday, but the Project 1 doc says Monday, April 6th. I'll have to check with Professor Hamilton, but I think that is the intention. It's due Monday, but we'll see. Tired, exhausted, but chilling. Yeah. It's the 6th. Okay. Alright, well, good to know. Wait, I need to refresh this page. Can I refresh this page without destroying the universe? Live streaming isn't available right now. Oh, come on. It takes 24 hours to activate my... Oh, it like logged me out. Super weird. I hope I'm still streaming. They're still talking, so... Okay, I'm still alive. Sorry about that. Save, how do I go to the thing, the dashboard thing? Oh no. We're gonna do this. Just gonna show me. I don't want to see my face. Blah. In bigness. And in health. Alright. Still struggle bearing. Yes. Aha! Project's due Monday. Alright, cool. We're back. Alright. Sorry about all that Hufflepuff. Let's get to it. We'll say the project's due Friday or Monday. Project's due Monday unless you hear an announcement otherwise that it's due Friday. So, we'll say Monday because that's what the document says. I'll talk to Professor Hamilton and see if that was intentional. I know you guys will be real salty if we have to move it up a few days, but we're still discussing what's going to happen with exams. They're on the calendar for next week, next Thursday, for us. We're still discussing them. It's probably going to be like a take-home exam type thing. So neither Eric nor I are fans of lockdown browsers or any of that stuff. Yeah, oh, awesome. Patrick has the general open. So, in Discord, if you want to chat there. So yeah, cool. So let's talk about program design. Today we're talking about program design. It's actually a very difficult subject that you really learn a lot of sort of on the job, but there's a bunch of stuff that people have figured out how to teach before you get to the job, which is good, and practices that we're going to start to get you guys to write more readable, cleaner code. And as I've been saying all semester, but will continue to say forever, it's really important that you write clean, readable code. It doesn't matter how short your code is, as long as it's readable. A lot of people will mangle their code and try to make it super duper short, and it will then become harder to read because they're using all this fanciness. So if you ever write a line of code, just a one line of code, and you go, I'm clever, that means you probably just made a mistake. You probably going to be hard for anyone to figure out. Nerdy competition ever. What would be the nerdiest thing to compete about? Some nerds compete to try to deliberately write code that's hard to read. So that's what they do, is there's a competition, and it's called code obfuscation, where they're deliberately trying to hide what their code is doing and how it performs. On this slide, these two things are compilable C code, and they make designs, fun designs, and they also do stuff. And so the competition, you're graded on like the design of your code and like how hard it is for the judges to figure out how your code works. Because this code you can run. It runs and it does stuff. Code golfing makes your code much less readable. So the one on the right will, I believe, take a string and make it into like a really short GIF or something. I haven't run it in a while. I ran a few of these. My favorite was the one on the left here, which kind of has this like Taj Mahal feeling. And if you zoom in on the slides, like if you have them at home, it says spectral leakage at the top, which I thought was fun. Each of the letters of spectral leakage, or of spectral there, are their own variables, because code obfuscation. So the code on the left-hand side produces a waveform sound. So what it does is you give it a string, and it will produce a waveform of like audio, like it'll produce a sound file. Who, if you look at the waveform, the frequency over time of that file, it will spell out that word, or that string that you give it. So I got this code, I compiled it down. I had to install a bunch of stuff to get this to work. It took me way longer than I would have liked, but I have the sound, and I hope I hope this will work to play it for you guys. How do I know? Advanced audio properties. I hope this works. Oh no, what happened? What happened to Chrome? Oh, okay. Alright, so I'm going to play the sound. This is the sound. You can actually, if you listen carefully, hear each letter of Yo 201. I just played it twice by accident. So there you go. Beautiful. Darkness. Has it been darkness the whole time? Why is it still darkness? Oh my gosh. Oh my gosh. Today has been like rife with... Oh no. Why have you betrayed me? What is global cancel? What? I didn't even change anything. Well, I'm sorry, guys. Oh, I need it. Oh, my drink is empty too. What a bad day. Oh, damn. Okay. Jeez, a whiz. I even checked earlier. Did you guys hear the sound though? You did hear the sound? Was that a yes on this? Are these all yeses on the sound? Imagine if he was a streamer. I've seen streamers do this. Back when streaming was new. The slides are very much not present. You can't see the slides. But you guys heard the sound. We might run a little tad over today. These title slides, or this title slide has code that has been deliberately made hard to read. And they put it in fun designs. the code on the left takes the... Oh, actually, I was looking at my phone and I was like, why is my phone paused? The code on the left takes a... So, Yo 201 was what was playing there. So, and I have this in the... That little bit of... Those are 2 terminal commands. I kind of have in here for my reference in case I have to put together this thing, because that's what I had to figure out how to do. Alright. So... I'm going to skip the review today because let's get on straight into program design. Where is Charlie? That's a good question, Agatha. Charlie, you want to come hang out with me? Wow, no, he's on the couch. It's hard to get that dog off the couch. If he's snuggling on the couch, yeah, it's not going to happen. Okay, so... Program design. Let's talk about program design. I will go recover Charlie at some point so we can have a Charlie moment. Yeah, class is better than streaming, but I'm so sad. I miss the class. Anyway, so a good program design is important. My gosh, it's so much easier to read and maintain. And what we mean by maintain is debug over a long period of time. The more poorly written code is, the harder it is to actually find and squash bugs. And also, it's harder to improve poorly designed code. So if everything's sort of all this mishmash, if you put everything in one function, and you have one function that's 10,000 lines of code, it's going to be really hard to kind of filter through and figure out how to improve a certain bit of code. Yeah, you're going to have to practice good design, and you have to practice it. So you have to keep trying to do good design. The hard thing is that it's when you practice coding, the compiler will immediately say, yeah, that works, right? But design is something that you're actually going to have to pursue feedback on. And this has been true for me for a long time, forever basically, is that when you're working with people, when you come up with a way to organize your code, when I would do it, I would go find another developer and be like, hey, does this make sense the way I'm organizing this? And, the core staff for 201 and the core staff for 202 from here on out will be resources for you to come and say, does this make sense? Is this a good way to organize this? Am I attacking this problem correctly? And so I get a lot of questions like that, and they're really great questions to get because it shows that students care about how they're designing their programs. So Python's not going to complain about you. C++ is not going to complain about you having bad design. But people who work with your code, including you, will be mad at you for bad design. So cool. All right, so modularity. Modular code is code that allows certain parts of it to be removed and added without disrupting other parts of the project. There's a lot of things in our lives that are designed with modularity in mind, so think about that. Let's see in chat, come up with some examples of things that are developed with modularity in mind. Fancy Mandarin. Doi. That's doi, right? I can't quite read it from here. So yeah, what are some things designed with... What are some things that you can replace parts on and not have to replace the whole thing? Things are less modular nowadays, but nowadays it's hard to make a modular, circuit board. Anybody? Nothing? Nothing in the chat? Legos. Thanks, Matt. Functions. Oh! No, I mean physical objects. USB on computers. Taxes? I'm not quite sure what you mean by taxes. Computer parts. Dolls. Pizza. Cars. Pizza. I've never tried to repair a pizza. Well, actually, I take that back. I've probably tried to repair a pizza before. Not the fine arts elevator. Yeah. Just go to the other buildings. Phones at one point. Communism. Okay, all right. You guys are getting a little bit off the rails. But yeah, cars are an excellent example. So ding, ding, ding. Probably the best one out of this set. People, if we consider kidneys, right. So cars... The thing about your car is if your windshield wiper breaks, you don't need a new transmission, right? You can get an individual component of your car replaced or repaired without it having to have ripple effects throughout the rest of your car. So, if your alternator busts, that doesn't mean you also need to replace your tires, right? So, modularity is the ability to design something so that individual failures or changes to individual parts of a thing can not have as big of an effect or any effect on the other parts of that whole system. Another thing is you could get your tires... You could replace your tires with snow tires with like chains on them or whatever, and you don't have to change any other part of the car, right? So it allows you both to repair and replace things that are borked, but also let you make changes to certain parts without having to make changes to every part or a lot of parts. So the more modular something, the more you can modify individual constituents of that system without having to modify the overall system. Functions, which I think I saw... Oh, airplanes, absolutely. My gosh. There's still planes from the 50s flying around. Most of them are different. Like, the whole plane, it's basically just been, like, no original part is on that plane. It's just a collection of parts that have been replaced over time. But, borked. Bork, Swedish chef. Okay. So, functions and modularity. So, functions are the current tool that you have to make your programs modular, because you can take an operation that you're performing, put it into its own function, and then if you need to make changes to how the internals of that function works, the rest of your code doesn't care, right? As long as you keep the thing that you return the same and the parameters the same, the stuff that goes in and like the stuff that happens inside of the function other functions don't really care about that so much. And you could even swap in and out new functions, and like you have to make minimal changes to the rest of your code. Whereas if you're not using a lot of functions, if you haven't written modular code, then you're gonna have like really long functions, and it's gonna mean that like when you try to change something out, you're gonna end up modifying a lot of code to accomplish that. So one of the reasons we use functions is to cut down on repeated code. Is one of the okay, we are moving the exam. The exam's going 1 week later. Thank you, Professor Hamilton. I lost my train of thought. It's easy for me to lose my train of thought. My train of thought runs on very narrow rails. Yeah, so to reduce code duplication is the primary use of a function. And then the other uses of functions is to make your code more modular so that if you make a change in one place, you don't have to make a change everywhere. So how do we plan out a function? So a function takes a set of inputs and then creates an output. So you have to think when you're designing a function, well, what inputs does it take and what does it do with them to generate outputs? But first, a would you rather. Actually, I'm going to delay the would you rather. Oh, no. So let's look at some live coding. Delay the would you rather. We'll do it later. This is the office hours bot. I'll show you guys the office hours bot, but it contains many forbidden magics. No, iPhones are deliberately not modular. Some... I know, you're sad. I know, I deprived you of a Would You Rather, but it'll be back. It'll be back. Okay, so... Sea lion? No. Pie charm? Why have all of my captures busted? Ta-da! Alright. I'm gonna be even more paranoid as usual. I'm sure all of you in chat are gonna be like, oh, he has a black background again. Is he gonna notice that? I did. Alright. So here's some not very modular code. I've got everything in this main function that I've written. It's not the most modular thing in the world. So what do I do about this? How can I make this more modular? It's coming, it's coming, it's coming. How do I make this more modular? Well, you guys think about that. I'm going to refresh my beverage, and I'm going to collect a dog, even though he's very comfortable looking. Hello, Jules. Come here, you. Okay. All right, so I got my Charlie here. We're ready to rock. How would we make this code more modular, right? So we have some repeated code, and if we wanted to change something about all of this code, it would be a mess. So what we're going to do is we're going to take this code, and I think method name get input in range. Why did it go down here? Go back up here. Great. Okay. Ta-da. Okay. So get input in range, and we're going to do min value, max value, and oh shoot, it's Charlie. Min value, max value, prompt. And so we're going to take this code, and I'm going to do put this prompt here, and then I'm going to put the prompt here. Cut this out, prompt. And then we have 0 and 150. So we're going to do, age, and then we're going to do min value, age, max value, And then let's change age's name to be user input. So now I've made this nice generic function, and down here I can call it with what is your age, oops, and we'll call it with 0, 150. Okay, and then here I can just grab this and then bloop to get input in range 0, 120, and pop that in there. Boom. Oh man, Charlie, your breath is kicking. Whoa, whoa, yo, ha, yeah. He just kind of like looked up at me and, oh gosh, it was powerful. And then this one will be the same with 0 and 2. And then down here with D and D stats, it's 3 and 18, right? So will be user stat equals, whoops, 3, 18, and then the prompt will be like that. What is the problem? Doesn't return anything. Oh, whoops. Okay, so now my code in here is much more, my code overall is shorter, but the goal of this wasn't to make my code shorter. So the problem is a lot of times people notice that when they make these kinds of improvements to their code gets shorter, which is actually kind of nice, but it's not the point of this. The point of this is to make the code more modular and to lower repetition. So now I have a lot less repeated code in here. And also if I just, say I had written this code with a bug and I had and instead of or, I would have had to go, that bug would have been written in 4 different places. But by putting it inside of a function, PyCharm's like, that's not possible. But, oh, Charlie, what? You're so bad at sitting in a lap. He keeps like falling through between my legs. He's like, because I want to be head. So the purpose of this, though, is to make the code more modular so that it's off to the side and that we can make changes to it and reduce repetition in code, because reducing repetition is awesome. Yes, you should make constants for the numbers. I didn't in this exercise. So that would be the next way that you improve this code. There's a bunch more things that we could do to make this code more readable. This code is gnarly. But yeah, good point. Good point. All right, so let's switch back to Zakat. What? So breaking down a large problem is hard, right? So when these projects were giving you pretty large problems, you have to break down into functions. And it's kind of hard to figure out what functions to write. So it's for this that you can use top-down design. So you can pull out notebooks. You don't need to code for this. We're going to take a big problem and we're going to split it apart into smaller problems and then break those into even smaller problems, like we're writing an outline. Okay? So, chess. I'm going to ask you guys to build a system that plays chess. And a lot of you be like, oh my gosh, I don't know how to do that. Right? The thing is, you actually probably do know how to do that if you know how to play chess. But that's what Wikipedia is for, to learn up on the rules of chess. So, if you're given this kind of big problem, what you want to do is break it into really like big parts, right? Like, so what would we have to do for chess? So usually I would give you guys time to discuss this amongst yourselves, but we're all sort of siloed away from each other, which is sad. So what do I mean by high level? I mean, try to stay away from details as quickly as possible. So a lot of times when I propose this in class, someone will say, oh, well, you have to code how a knight moves. And I'm like, yeah. But that's jumping down to a really tiny detail, right? There's some much bigger sub-programs that we need to write to manage chess. One of them would be determine whether the game is over. Another one would be pass turns between two people. One would be prompt the user for the turn that they're going to try to take. Another one would be validate what move the user inputted, and then perform capturing and all this other stuff. And eventually, if you write this outline out, you're going to make more and more detailed things down till you get to the point where you're talking about figuring out, well, if they moved a knight, what are the valid knight's moves, and so on and so forth. Each entry in your outline will then become a function in your resulting code. And this is very, very much something I still do for large projects, as I sit down and I break them out into functions first, and I go top down. And a lot of times I will even implement it top down, where I'll make the big components first. They might not do much, and then kind of slowly and gradually push down into implementing the small components. Okay, so here's an example that we came up with last semester. So we're going to play chess, so that's at the top level. Then we want to be able to tell when the game is over. So that's a function that's going to be like, is game over? Then passes turn control from one player to another. So that's going to be like next turn or something like that. Let the player make a move. So player take move or something. Take move would be a name for that function. And then ask the user for a move could be a function, and then you get a move back. And then there could be another function that's get valid moves for the piece that the user selected to move. And then that down here is where you figure out valid moves for pawns and queens and castling and capturing and passant and all that other fun stuff. But it's kind of down there, right? And the thing is, if you start with those little detailed things, it's harder, I think, for a lot of people to conceptualize how to combine them if they haven't already thought about how they get combined. So what you can do is you can do this whole outline out, and then once you have the outline and you have a plan in your head for how you're going to combine these things, then you can start implementing get a move for a pawn, right? You can start down at the bottom thing, and you can test those things as you write them, because you can like put a grid in that has a pawn on it, and if it gives you all the correct pawn moves, you're good, right? So yeah. What if the variable is set to 3 and then it's changed later on? Then it's a variable, not a constant. Agatha's on it. Okay. So yeah, so this is an example of doing top-down design. Now, you can implement from top to bottom, or you can implement from bottom to top, bottom up or top down. It's really your choice. I usually do top-down implementation. Is that true? I'm trying to think of a big project I did recently. Yeah, I usually do top-down. It doesn't end up being that. Once you start getting to really large projects, it kind of ends up being like you make a design, you work with it for a while, and then you're like, God, this is dumb. And then you redo it, and so it becomes more iterative. But each iteration, I go top-down for both the design and the implementation. Okay. So it's okay if your top level things, like your A, B's, and C's here, are really vague. Because the question is, how do you know when to stop? How do you know when you've gone deep enough? You know when to stop when you've written an outline element that you can think like, I can write like 8 to 20 lines of code to accomplish that. And I know how to do that. If you still don't know how to do it, you have to think a little bit harder about, how to break that apart, right? So you keep on driving further and further down. And what I usually find with students and people that are learning how to program is that you will need to push further down in your design thing. Like, you'll need to get more specific. Uh-oh, I'm getting a phone call. Why? Just, okay. Not now. I'm sure that's probably my parents. My mother has a keen sense for when I'm unavailable. Yeah? Really? You want to go back to the couch, don't you? Your breath really smells. I'm kind of tempted to let you go back to the. I know. It's got I know we skipped the would you rather even. I know this is actual. It's a farce. Yeah. Oh. Really? All right, I'll just put you down. I know. He wants to go back to the couch. I'm not as comfortable as the couch. Goodbye, Charlie. Actually, we'll say goodbye. Say goodbye to... Oh, may have hit his head on the table. Bye! Ugh. All right. So here's another example of... There he goes. Walking back to the couch. Here's another example of breaking down, making a move. So there's a whole bunch of examples in here. Your project 2 is very, very likely to be a board game. So when you're thinking about what functions to make there, you can come back to these slides and it won't be chess, but you can kind of think like, oh, well, here's how we broke it apart for chess. How would chess be similar to this game? So you should test each function as you write it. You should test as you go. You can write functions bottom up, where you write your code sort of for the most indented portion of your outline, test them, and then start combining them in meaningful ways. Or you can also write top down, where the thing is, if you're writing make a move... Oh no, I lost my pointer. If you're writing make a move, and then you, like, say you write make a move, and then you want to show the valid moves for a pawn, and so on and so forth. Or you want to write make a move, and you write all of these function calls, but then the functions don't have anything in them. And what you can do for that is just name the function and have it say pass inside of it, and that way you can actually run your tests. Do not submit a finished project with pass in it, though. It's against our coding standards. But you may use it in an intermediate sense to stub out, make functions that get called but do nothing, but just to kind of organize your thoughts. So you could write this make a move function, which would call change what player's turn it is, get user's move, show valid moves, move piece, perform capture. You could call all 5 of those functions, but only have one of them actually do stuff. And so you can keep going until you get all the way down to these more bumped in parts when you're actually writing the code, but you can still test as you go because the code will still run. Man, we're having a constant jamboree over there. All right. How do I write tests? Okay, so this is a big question. How do I write tests? So when you're given an assignment, there's requirements in the assignment somewhere. And those requirements, they're called requirements. They may not be listed under a heading requirements. But what requirements are the things we require you to do, features you must have and how they perform. So for each of those requirements, you should take it upon yourself to write at least one test for each of those requirements. This is an excellent, excellent habit to get into, because by the time that you get to 202, 341, or 421, or out into getting jobs, like, this never leaves this concept of testing. It only actually grows. So learning how to do it now is super, super important. It will benefit you a lot. And so, I just have take it from, that's a holdover. I don't. Boop, 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 Boop. So tests help you think about how to tackle a problem. So if you write tests out, they'll even before you write your code. If you write your tests out beforehand and then run them as you go, if you test as you go. If you write your tests out beforehand, they'll help you think about how you're going to actually write your code, right? Because what your tests are going to do is they're going to call your functions with certain values. Like, for example, in the chess problem, it would be, I'm going to call the make move function with this pawn to move it here. Or I'm going to call the get available moves for this knight on a board, right? And so that test would then look at what the available moves sent back were and then check and make sure all of the correct moves were there. If you write all these tests beforehand, it'll make you think about how your code's going to work, how it's going to be organized, but it'll also help you find bugs as soon as you write them, because as you're writing that knight move code or whatever, you're going to have tests that you can just run. You can just run them. They're right there. You don't have to write them anymore because you already wrote them. And so you can just run your tests and be like, haha, I did it. And you'll be much harder on your unwritten code in terms of writing tests than you are on code you've already written, because you'd be like, oh, I've made this beautiful thing. Oh, you're so beautiful. I don't ever want to hurt you. I won't give you hard tests. You're going to ace all your tests, right? So you don't want to be that. You want to write really hard tests and then just throw your software at it when they're written. All right. Now, before we get into practice with the current project, it's would you rather time. So, would you rather one day a week you're able to eat rubber, and one day a week you can eat normally, and other days you eat nothing, but you're still fine, you still maintain healthy weight, but you have to eat 2,000 calories of rubber on the day that you eat rubber, and you can only eat rubber and drink water. That's it. You can't eat anything else. Or you can only type on any keyboard, physical or virtual, with your toesies, with your toes. And for some of you, if you don't have toes, somehow your toes grow back and now you can type with them. So maybe that makes this a winner. But would you rather be able to, would you rather be forced to eat rubber once a week and then not be able to eat anything else? So 1 day rubber, 1 day actual food. I don't know why this one's so complicated. And then 5 days, the remaining 5 days, you eat absolutely nothing. What does 2,000 calories of rubber look like? That's a good question. Do I still get hungry? Only on your rubber and only on your eating days. Same typing speed? No, you gotta relearn how to type with your toes. You can't, voice to text will no longer work for you instead of typing. Are you gonna lose weight for the first one? No, your weight will remain normal for the first one. Can our bodies handle eating the rubber? Yes. Your bodies need the rubber. If you don't eat your rubber allotment, then you'll start to lose weight and become malnourished. The first one is a money saver. I hadn't thought of it that way. The first one is a money saver. The file name is input. Oh, Ryan's being professional. That's good. Okay. Second one ruins my career. I already type with my toes. See? Can I use a mouse and something else with my hands? Yeah, you can use a mouse with your hands. You just have to type with your toesies. The first one sounds cool. Man, alright. Okay, I'm hearing a groundswell for... I might have to make the second one less unpleasant? I don't know. Okay, straw poll. Rubber or toe typing? Rubber, toe typing. IT duplication checking. We don't want anyone falsifying this very, very important poll. Okay, here we go. Straw poll. Live streaming. All right, well, vote there. Chat seems to be very pro the rubber eating. That's where chat's going with this.
Environmental effects.
That's true. The environmental effects would be good. You would be a lot less of a contributor to unfortunate environmental things. Does rubber get processed the same way as normal? That one had trouble getting out. With your digestive system, yeah, it goes through your digestive system, but your digestive system is magically able to process it, and the resultant is normal, we'll say. Okay. This is the first one I don't think the guy who always asks questions about babies can make a baby-related question. Usually there's a baby question to be had. All right. Rubber is an oil byproduct, so consuming more isn't great for the environment. Oh, no, rubber's from trees, yeah. Rubber, you're thinking of plastic, I think? Rubber is from trees. There are rubber trees. Yes, I'd like to order your finest rubber.
Yeah, just talk to the people in the Amazon that got fucked by Mr. Goodyear.
Yeah. Throw your car batteries into the ocean. What? What? Since all my classes are online, I'm kind of screwed if I pick option 2. Yeah, I mean, but the thing is, you might be able to get back reasonably high typing speed. And then yeah. Like, there's a guy who plays, I think it's Street Fighter, who, like, professionally, a professional competitive Street Fighter player that plays with his tongue. And he, like, is incredibly good at it. And I don't mean incredibly for using his tongue. I mean, he's just really good at Street Fighter. Like, wins championships and stuff. I'm sure some of you know about this guy. All right. Here are 2 requirements from the current project. So let's talk about, well, what tests would we write for them? How do we go about testing these as soon as possible, right? Because you want to test as you go. Test as you go. So how would we write tests? Well, ask where you want to go and make sure it's a valid location. So you're going to have some sort of function probably that asks the user where they want to go. So you could write a test for that. I mean, sometimes you don't necessarily write a test for it. So sometimes you just run the code and make sure that it behaves correctly. But then you'll have another function. So you see and means there's another requirement coming. Make sure it's a valid location. So you're going to have another function that makes sure that a supplied location is valid. So it'll probably be like is valid location, and then you give it the location in there. And so when you're writing that function, you should write a test for it that loads in the valid locations, and then the test says is valid location and gives it a valid location, and then that test is going to say if is valid location commons, if that's equal to true, then print test passed, otherwise print test failed, and so on and so forth. So you basically just write a bunch of if statements. The if statements call your function, and then compare the output of that function to whatever you would expect the output to be, and they print out passed if you got the expected output, or failed if they got an unexpected output. And then you can do this actually before you write is valid location. You don't have to write is valid location to test is valid location. It doesn't need to have code inside of it. Okay. So here's an example test. If is age eligible to vote 17, right? So since we're saying if that thing, we're expecting that it returns a Boolean. So we're saying if is age eligible to vote 17 is equal to true, print test failed, right? Because that function gave us an unexpected output of false, or of true. Otherwise, print test passed. So what's another test you could write for is age eligible to vote? What's another one you could write? So this is one test. How would we write another test? And these are called unit tests. Your each requirement that you test, you want to write little unit tests that test each little unit of the project that you're implementing. Should we write a different function for each requirement? Yeah. Generally. Not. Sometimes you'll merge a couple. It's a feel thing. And like that's why I said there's not a lot of like hard rules in program design, but that's why it's important to get feedback. And when your project gets graded, don't just look at the grade, but go see if the TA had any comments on your design or your organization or things like that. And then use office hours. You can use office hours to go in and be like, I just want to know, am I organizing this correctly? Or these are the functions I should have. Should I have more? Should I have less? Are they connected correctly? Does this make sense? Because the thing is, you'll be able to write code that runs and runs correctly that is not very modular, not very easy to read, might have a lot of repetition in it, and so, but it'll work. And so that's when we come in as the core staff to give you feedback on that kind of stuff. Most rubber isn't natural anymore. So we should write a different function for each requirement, yeah. Okay. So another test you could write is you just basically rewrite this if statement down here at the bottom. You rewrite this if statement, but you put 18 or 20 or something in there, and then you swap the test failed, or you say if not is age eligible to vote 19, meaning if the function says 19 is not eligible to vote, then you would print the failed message again, and then otherwise you would print test passed. And the beautiful thing about this is that you can write tests, and then you can test as you can go. Test as you go. As soon as you write code, you test as you go. You should really, really test as you go. I went over this last time, and I'm going to go over it again today, because if there's something I want you to take away from this class, it's test as you go. If I had, and I said this, again, I'm repeating myself, but if I could teleport back in time, and for the sole purpose of making me have more fun in college, I would go back. And there's so many things you could potentially say, but I would come through that vortex and go, Ben, test as you go, do it, you'll save so much time, and then, because you'll find bugs as soon as you write them. The hardest bugs to find are the ones that you wrote hours ago and you haven't tested, and then like you're writing this new fresh thing and you're like, okay, I guess I should test them. And like, think about it. If you write 5 lines, if you know your code is pretty good and you write 5 lines of code and then you run and a test fails, you're like, oh, my code is probably in 5 lines of code. If you write 40 lines of code and then you test that 40 lines of code, now you're looking for a needle in a haystack. You have much more ground to cover to find that bug, right? So keep the place where your bugs could be smaller. Is this always going to be the case? No, sometimes you'll run your tests and a bug will still be hiding in there that you don't find till later. But you'll catch so many bugs sooner, and it's an ounce of prevention is worth a pound of cure, certainly here. So make sure you test as you go. Test as you go. Test as you go. Go. It's so much easier. I wish I had known this. Also, test as you go. Some other things you should be made aware of is test. Should you test? Yes, as you go. Really? Yes. And usually when I give this class, I'm like, do you guys have any questions? And then everyone will raise their hand and be like, should we test as we go? And I go, yes. Your testing should always be above your going. You should. You should really do it. It's really important. I promise. Charlie does. Charlie tests as he goes. Jules tests as he goes. They do. They're very good software developers as a result. So don't disappoint Charlie by writing a whole bunch of code and not testing it. Run your code as often as possible. The more code that you write, the more anxious you're going to be about testing it, because you've built more of your beautiful baby. You're like, oh, you've gotten so big. I don't want to test you now. No, test a little bit as it goes. Just a little bit. Get it in there just as a little bit as you go. So it's really, really stressful to run your code. It feels like every time you get that red text, it's like, you're dumb and you're bad and you're wrong. You're not dumb or bad. It's just part of the process. You kind of just get used. I don't know why they had to make I guess red to draw your attention to it, but red is also kind of a you messed up big time. But testing saves time. It feels like a waste of time. I was not converted to testing as I go until I was until I was at a startup and they made me do it. And then I was like sitting there like, God, these nerds, this is a waste of time, right? I'm sitting there, because those if statements are not fun to write. You're not solving a fun problem. You're not doing anything clever. You're just writing tests. And it feels like really kind of like a waste of time when you're writing the tests. But then when you get to run the tests and be like, oh, I wrote a bug. Oh, and I found it right away. Oh, this is good. And so I was a pretty quick convert to it. So, yeah, you don't want to disappoint Charlie. He kind of has like a resting disappointment face, but you don't ever want to truly disappoint Charlie. So every little bit of time that you spend testing is going to save you time debugging. And as much as boring as testing is, it's much more pleasant than debugging, especially when you're under a time crunch. So I'll leave you today with a legend, a fable. There was a great programmer from lands beyond. She was revered by all. Some say she was the leetest there ever would be. The leetest. And once, right before a huge software release, I went to her and I said, Grandmaster, do you test as you go? And she goes, no, I test before I go. So do that. Be a Grandmaster. Be a legend and test as you go. Or even test before you go. Write your test before you go. For Project 2, we are actually going to be assigning you that you must write your tests before you go. So that to encourage you, this is a new thing this semester, to encourage you to test as you go, because you already have your tests written. It won't even be any extra time. You'll have written your tests and submitted them, and then you'll have them when you want to run and test your code. Okay? So that's today. Any questions? Oh, no. It's my face. The leadist. Any questions? I don't know, is there anything for me to show in Minecraft? I guess I could do that. Oh my gosh, it's only 12:30? I did 15 minutes early. The program design lecture usually tends to be an early one. Because there's not as much in-class exercises. It's mostly just me yammering about testing and testing as you go. Alright, I'm hearing calls from Minecraft time. Let's see. Alright. Portal. You want to see me play survival games? It's boring. I immediately go in there and try to min-max it. 15 plus minutes of Minecraft. And they were never seen again. I realized that my Minecraft is low frame rate. It's a OS X problem. Sorry. You're just gonna have to deal. It looks perfectly fine to me. It's like 90 frames a second. Oh, okay. So here we are. We're at Hirsch's place. Oh, it's gotten so elaborate. Here we go. Town of Salem. I've played a lot of Don't Starve Together. Where am I? This is so elaborate. Alright, I don't want to go deep into, like, Hirsch's mind, because I will never find my way out. Is Ryan in here? Oh no, Anna's in here. What is this? Oh, it's a ladder. Ooh. Uh-oh. Wait, do you have your own house, or do you squat in the TA houses? I have my own humble bungalow that I... Back at the spawn. It's Ryan! Ta-da-da-da. Oh, we gotta go see what Anna's been working on. Anna's here. Let's go see. Here's the cow house. Oh, new recipe. Oh, you punched me. Oh, yeah. It's punchy. The magical nether portal. Excellent. What's over here? Is this just the other side? This is epic. Very exciting. It's not very exciting. I could stream you guys. I've been playing Alex, the Half-Life game. Oh no, I'm gonna immediately get lost because I'm not paying attention to where I am. Yeah, yep, and I'm lost. Yep, don't know where. Oh, here we go. There he is. I need a texture pack. Mineshaft shortcut. I know Ryan's going to be a very sought-after developer because... Wait, to castle? This isn't the castle? Oh, right, there's a castle. Yeah, cart me. Hoo-hoo. Thanks, Ryan. I forgive you for punching me in the face. Oop. Are you enjoying? Yeah, it's amazing. I've been doing VR for a while because I use it with flight sims, and Alex is really good. It's probably like, oh man, welcome to the castle. Uh-oh, no. How do I stop the cart? I think if I get out, it just goes away. Oh well, there's another cart here, we'll be good. So let's check out Exit at Your Own Risk. Wow, this is insane, Ryan. I haven't been out here before. But yeah, Alex is a lot of fun. I saw a professor gave a math lecture in the first room in Alex using the whiteboard markers there, and I thought, interesting. But I don't know. It seems like a little bit. Maybe I'll do a very extra special side lecture. What's over there? It's lit. Uh-oh, I'm gonna get zomboided. Hey, buddy. What you doing? Hi. Saying hey? No autographs. No autographs, please. No, sir. Okay. So yeah, this is kind of crazy. Drew, do it. Uh-oh. I have Alex. I don't have Boneworks. I don't know why I don't have Boneworks. I guess I just haven't, like, felt like I had the time yet. That's probably going to be a summer thing for me. But yeah, I mostly do flight simming in VR, and it's awesome. It's probably the most, other than Alex now, the most full-fledged, like, VR application. Look at this thing. This is like Ryan Barron's Pit of Doom. You laugh, but you haven't seen it. I feel like he's building an orc army in here. This is intense. Monster Hunter? Is that a VR title? Yeah, Alex is good. Oh, I can only come in via cart this way. Wow, fancy pantsy. The persistent narrator that's usually what? Oh, I can't come back in through these doors. Oh no. I've made a horrible mistake. Was I saying something? It's really hard to talk and craft and peruse. It's an and gate? He's got a zombie farm. Hey, buddy. No autographs, please. Oh, I have to get both levers. Yeah, you've made some sort of puzzle world. Left is spawn. Okay. But yeah, this is how I know Ryan's going to be an excellent developer, is he's very thoroughly documented his work here. Doop. And then this always happens where I'll put it down and it'll escape immediately. There's probably a smarter way of doing it, but I don't know how. What? Get out of here. God. Just trying to have a nice peaceful ride. Oh, you're gonna get in my way too. Get out of me way. I'm trying to go home. Oh yeah, so the persistent narrator in Alex is Reese Darby. I don't know if any of you have watched Flight of the Conchords, but he plays Murray, their manager. And I love that man. He's hilarious. He's the only stand-up comic I've ever seen do a bit about the Transformer toys from like the 90s, which were amazing. That's the like only toy I had as a kid, were the little Transformers that you could, they'd be like, well, I mean, you guys all know what Transformers are, but they were amazing. And back then they were made with like full metal. It was intense. And yeah, I would get some relatives who didn't know me that well would get me like G.I. Joes or something, and they'd give it to me and I'd be like, what, you mean to tell me this is just a dude? Like he doesn't become a car or something? Really? The Teenage Mutant Ninja Turtle is just a turtle? I don't know about that. There was a turtle. Oh, it's a skeleton archer. Yeah. Line of sight pull. Huh? Get over here. Get on my level. Okay, you're in the water. This is with a trackpad, guys, so don't judge. Alright, let's see what we got here. Oh, Sean has his own Portal of Doom. For communist movement sympathizers only. What is going on with the TAs? They have portals to nether realms. They're starting to create some sort of political movement. There's the Pog sign. That zombie said, nope. That's Skeleton. Alright, let's go see. I'm low on health. Do I have some delicious foods? No, I only have, like, zomboid flesh. I think there's food over here, though. That is a lot of eggs. Apple? Can I eat an apple? The night is dark and full of zomboids. That's a lot of... Oh, that's leather. Free stuff. Wait. I had forgotten when I started playing this game again that the monsters aren't afraid of the torches. They just don't spawn near them. Oh, look at this. There's flowers. Uh-oh. Anna must be AFK. It's still pretty Spartan in here. Man, there's still considerable delay. see what's going on. Oh wait, so then there's this other little house I found. I think it might be Mansour's. Got 3 more. Oh my word. Yeah, this screams Mansour. Screams Mansour. Why? Because it's festive. Uh-oh. Stuck? Boop, boop. Well, this was fun. Welcome. We've got this nice little tree hut out here where you can see our POG sign. Oh, there's something behind the POG sign. I kind of need to know what. It's almost daylight. I think it is day. Oh, hey. Oh, you're feeding me. Oh, excellent. I'm like a baby bird. Okay, excellent. Thank you. Uh-oh, now you're hitting me. Oh no, that's a zomboid. Get him. Oh no, we're killing someone's decorations. Oh gosh, it's a zombie. Oh, hey ho, and a ha, and a ha. Ta-da. All right, well, time to nosh again. Noshed. How is it? Oh, because it's like all. Yeah, I know, weather clear. Bloop! Come on. I am the admin. I stop the rains. So I'm tired of getting booped by monsters. Alright. This is the power that you wield. Let's see, is there anything behind the POG sign? I'm gonna go around this. Somebody made like roads? Oh, this is the road that leads up to that house. Oh yeah, the map. Let's check out the map. Oh yeah. Oh, you've labeled it. Wow, this is. Oh, there. See, there's some secret house over there. Interesting. Good stuff. I stopped the rains down in Africa. It would be right there. Yeah, that's what I figure. All right, I think this concludes my broadcast day. I have to go write a 341 exam. Yeah. Have fun, everybody. Be good to each other. Be excellent. And work on your projects. Practice good design and practice it. So, yeah. Have a good day, and I'll see you on Thursday virtually, if not before. I haven't found a good way for me to hold office hours yet, because a lot of you tend to want to, when you come to office hours, you want me to look at your projects and things like that. So generally what I've been doing is I'll just sub in if there's a long line, if I see a long line in Discord and I have the time, I will, you might get me in the Discord office hours, which I know I can already sense your disappointment, but you might get me in the 201 office hours. So that's what I've been doing, is I just sub in. But yeah, and I'll be keeping an eye on 201 because 201s do more or less this week and 341s do next week, and so I'm just not gonna. Those nerds can wait for help, even though I'm glad that most of them are starting early. All right, bye everybody. I'm stopping the stream now. 3